In this lesson, we're going to study how to graph linear equations. And the linear equations we're going to look at in this lesson are going to look like this. So the first one we're going to call standard form. So the standard form. And it's going to look like this. Ax plus by equal c. So notice you're going to have two variables involved. So when you graph these linear equations, you're going to have two variables. And notice that the exponent of x and y are both 1. So that's what makes this a linear equation. Okay. The other form we're going to look at is this form. I'm going to write it out first, and then I'll mention it what it is. So when we do this one of the other ways is that you're going to see you can get y by itself. And so when you get y by itself, you get y equals mx plus b. And the m and the b do mean something. And we're going to talk about that in another lesson. In this lesson, we're going to be focused mainly on plotting points, not using any other method, but just plotting points. Okay? So this, though, is called slope-intercept form, and that's going to be in another lesson. So slope-intercept form. So those are the two forms we're going to look at. So we're going to look at graphing linear equations that's in standard form, and we're going to graph linear equations that in which you see y by itself, and that's actually called slope-intercept form, which we're going to talk about in another lesson. Okay? Now, before we do that, before we start looking at how to graph linear equations, there are a couple of things you have to understand. And so first of all, let's talk about what does it mean? What does it mean? So what does it mean when we find a solution to an equation? Okay, so that's the question. So what does it mean when we find a solution to an equation? So let's look at this example here. We're going to start out with a very simple example. So let's suppose we had this example and we call it number 1. We have x plus 4 equals 7. So this is the easiest type of linear equation that you can solve. And notice in this case, though, you only see one variable, right? All right, so when you're solving this linear equation, you're asking yourself, what number plus 4 is 7? So intuitively, you can tell me what the solution is. So in this case, the solution is x equal 3, right? So when finding the solution to an equation, you're finding the value of the variable that makes this equation a true statement. That's what you're doing. You're finding the value of the variable. What real number can I substitute into the variable that will make this equation a true statement? And in this case, there's only one solution, and that's 3. 3 plus 4 equals 7. Okay? But let's look at this one now. So let's look at this. So let's suppose I had this example. So example 2, we have y equals x minus 3. Notice that we have two variables. We have two variables here. Okay? And so you want to find out what value of x and what value of y would make this equation a true statement. Now, when we talk about linear equation in which you see two variables, see this is one variable, this is two variables, you're going to write the solution, as an ordered pair. So the solutions, you're going to write the solution as an ordered pair. Okay, so let me remind you what we mean by an ordered pair. So an ordered pair is xy here, since we're dealing with the variables x and y. So it's xy. In the coordinate plane, remember in the coordinate plane, the horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Okay, and so when you plot the point, so let's say we want to plot the point 4, 7. All right, when you plot the point 4, 7, you're going to start at the origin. Notice I use the word origin. Okay, and the origin is the point where the y-axis and the x-axis intersect. So here's the origin right here. The origin has coordinate x equals 0 and y equals 0. So this is your x, this is your y. Ordered pair, x, y. X goes first, y goes second. So if I want to plot the point 4, 7, you're going to go 4 units to the right from the origin. 1, 2, 3, 4. So do x first. So the x, you go left, right. The y, you go up, down. So x-axis, right, left, and then y, up, down. Okay? So from the origin, you go 4 units to the right, and then 7 units up. So 1, 2, 3, 4, 5, 6, 7. So when you label the point, you label it as an ordered pair. I'm using the word ordered pair. So you list it as an ordered pair. So this ordered pair is 4, 7. Okay? Now, if you want to plot the point, let's say negative 3, 6, negative 3, 6, if you want to plot that point, then again you store the origin, and since x is negative 3, you're going to go to the left 3 units, 1, 2, 3, and then y, this is x, this is y is 6, you're going to go up 6 units, 1, 2, 3, 4, 5, 6. So this is the point, and you're going to label it as an ordered pair, and that's the point negative 3, 6. Okay? So that's what we mean by an ordered pair. That's what we mean by an ordered pair. And by the way, notice that the x and y axis divides the plane, the coordinate plane, into 4 quadrants. So this is quadrant 1, you go counterclockwise, quadrant 2, quadrant 3, and quadrant 4. Okay? All right, so that's what we mean by an ordered pair. Okay, now, so what I want to do, though, is find out what ordered pairs make this equation a true statement. All right, and it's very easy. All you're going to do, the easiest way to do this is to use a t-table. So I'm using the word t-table. See, it looks like a T, right? T-table. So we're going to put x here and then y here. All right. Now notice y is by itself. So if I ask you is 4, 1 a solution? Is 4, 1 a solution? What are you going to say? Is 4, 1 a solution or not? Yes or no? Well, just like we did here, x equal 3 is a solution because when I substituted 3 into x, 3 plus 4 is 7. So if I ask you, is 4, 1 a solution, all you do is substitute in place of x, substitute 4, and in place of y, substitute 1, right? All right, in the equation. Okay, so here's what we have. Y is 1, so the question is 1 equal to x, which is 4, minus 3? Well, what's 4 minus 3? 4 minus 3 is 1, and 1 equals 1. So the answer is yes. Is 4, 1 a solution? The answer is yes. Okay? What if I asked you this? I'm going to label this as 2a. What if I asked you is negative 3, 7, negative 7, let's do negative 7. Negative 3, negative 7 a solution? Is negative 3, negative 7 a solution? All right, well, what do? How do you determine if this ordered pair is a solution to this equation? Well, all you do is in place of x, you substitute negative 3, and in place of y, you substitute negative 7 and see if those are equal. Okay, so y, which is negative 7, and you want to see that's going to equal x, which is negative 3, minus 3. Well, what's a negative 3 and a negative 3? Well, that's a negative 6. So is a negative 7 equal to a negative 6? And the answer is no. So is this point a solution to this equation? The answer is no. Okay? And that's what you do. If you want to find out if a ordered pair is a solution to an equation, to a linear equation in this case, you just substitute those values of x and the value of y into the equation and see if those two sides are equal. So let's do one more with this. So is the ordered pair negative 5, negative 8 a solution? All right. So an ordered pair is a solution is if when you substitute the values into the equation is a true statement. So this is x, this is y. So in place of x, I substitute negative 5, and in place of y, I substitute negative 8. Okay? All right, so here we go. Y equals, so that's negative 8. You want to see if that's going to equal x, which is negative 5, minus 3. Well, what's negative 5 minus 3? Well, negative 5 minus 3 is a negative 8. And is a negative 8 equal to a negative 8? And the answer is yes. So that is a solution. All right. Now, whenever you use a t-table to graph, what you're doing is you're graphing, you're plotting the solutions. All right, and we're going to talk about that again in a little while. So here we go. So here's what you do. If x is 0, what's the y value? Well, all you do in place of x is substitute 0. So 0 minus 3 is a negative 3. So this is a solution. So this is a solution as well. So when x is 0, y is negative 3. If x is, let's say, 4, I get 4 minus 3, which is 1. That's a solution, which you already knew, right? Because I asked you that question earlier. Is 4, 1 a solution? And the answer is yes. If you let x be negative 2, let's see what we get. If x is negative 2, I get negative 2 minus 3, which is a negative 5. So that is also a solution. So all of these are solutions. And notice I'm just using integers, but you could use a decimal as well. So 4.6, let's say. 4.6. So you can substitute any real number for x. And you can find the y value that will make this a true statement. So if x is 4.6, you can say 4.6 minus 3, which is 1.6. So that's also a solution. So the point is this, though. How many solutions are there? There are an infinite number. Because you can use any real number for x. There are an infinite number of solutions for y equals x minus 3. Notice when we did that example number 1, how many solutions were there? That was just 1. So here, there's only one solution. There is only one solution. And the solution happened to be x equals 3. So there's a finite number here. There's an infinite number here. Okay? All right, so that's what we mean. That's what we mean when we find a solution to an equation. So when we find a solution to an equation, you're finding in this case, the two variables, you're finding the x and y values that will make this equation a true statement. You're finding the ordered pair that will make this equation a true statement. Okay? All right, so now, here's what I want to look at next. And here's the question. What is the relationship between the solutions of an equation and its graph? So remember a while ago in example 2, I looked at this equation here, this linear equation, and I found a bunch of solutions, right? I found a bunch of solutions. And how many solutions are there? There are an infinite number of solutions. Okay? All right, now I'm going to go back to this question. What is the relationship between the solutions of an equation and its graph? All right, so listen carefully. That equation we just looked at, this equation here, y equals x minus 3, this is the graph of that equation right there. That's the graph. Okay? This equation, here's its graph. All right? Now, question again was this. What is the relationship between the solutions of an equation and its graph? Well, remember, the solutions, there are an infinite number of solutions here, but here are some of the solutions right here. So let's plot the point 0, negative 3. That's a solution, right? So if I look at this plane right here, and I plot the point 0, negative 3, remember 0, negative 3, remember how to plot that, 0, negative 3, and let me go ahead and kind of do it here. 0, negative 3 means, see, x is 0, so that means you stay at the origin. Y is negative 3, so that means you go down 3. 1, 2, 3. So this is the point here, 0, negative 3. Okay, so just make sure you remember how to plot points, because that's a prerequisite for this section. So when I go here and I plot the point 0, negative 3 in this plane, notice 0, negative 3 is right here. That's 0, negative 3. All right? Let's look at the other solution. Another solution is 4, 1. Now remember, there's an infinite number. In this case, I just listed 4 in this t table. 4, 1, notice 4, 1. 1, 2, 3, 4, 1. Here's 4, 1. Let's look at another one. Negative 2, negative 5, right? So if I plot that point, negative 2 means I go to the left 2, and negative 5 means I go down 5. Well, that's this point here. Negative 2, negative 5. So I'm going to ask you this. Again, here's the question. What is the relationship between the solutions of an equation and its graph? All right. Think about this again. So you see these ordered pairs? Those are solutions, right? And look at the graph. What do you notice about the solutions of an equation and its graph? So the solution of this equation in relation to the graph is what? All right, so here's the idea. All right, listen carefully. The solutions of an equation, and I'm going to put here in this case the solutions of a linear equation lie on its graph. So notice if I were to find more solutions at an infinite number, the solutions would lie on its graph. So in other words, saying this is that the graph of this equation are the solutions. So the graph of this equation are all of the solutions. Notice we have arrows on both ends. All right, so it keeps on going in both directions. So another way of saying this is this: the graph of any and we're dealing with linear equations. They could be for any equation though. Okay, so the graph, and I'm going to put equation. The graph of an equation. The graph of an equation represents the solutions to the equation. So whenever you're graphing, you are graphing the solutions. All right. So every point on this line, is a solution to this equation. Every point on the line is a solution to the equation, and in this case, y equals x minus 3. Okay? All right, now listen carefully. Look at this point right here, and let's call that this point here. All right, this point here is not on the line, right? So that point is off the line. And this point, the coordinates of that point, that ordered pair here, is 7, and then that's negative 6. So that's 7, negative 6. So here's the question. Is the ordered pair 7, negative 6 a solution to the equation y equals x minus 3? What's a very simple answer? Is the answer yes or no? First of all, is the answer yes or no? Is 7, negative 6, is the ordered pair 7, negative 6 a solution to this equation right here? And the answer is no, right? So the answer is no, and then the question is why? Why is the answer no? All right, a very simple response would be no, because the point, no, because 7, negative 6 does not lie on its graph. All right, because the point 7, negative 6 does not lie on the graph. Remember what we just said, every point on that graph is a solution to its equation. Because when you graph an equation, you're graphing its solutions. So since this point here does not lie on the graph, then that cannot be a solution. And it's not, because if you check it, all right, so let's check. Let's check let's check 7, negative 6. All right, into the original equation, y equals x minus 3. Y equals x minus 3. So in place of x, you're going to substitute 7. In place of y, you're going to substitute negative 6. So negative 6 equals 7 minus 3. Is that a true or false statement? Well, 7 minus 3, 7 subtract 3 is 4, and negative 6 does not equal 4. So that's why it does not lie on the graph, because it's not a solution. In fact, all of these points over here, that's not a solution, that's not a solution, that's not a solution, and so on, right? All these points are not solutions. Not solutions. All these points here, in fact, all these points outside, all right, so there are an infinite number of points, right? So all these points are not solutions. All these points. The only solutions to this equation are the ones that only lie on the graph. Okay? All right, now let's look at some examples. Okay, so now we have this example, and it says this: the graph of y equals negative x minus 4 is shown below. So this is the graph, and in a little while you're gonna see how to graph this, and it's very easy, especially if y is by itself. All right, so there's the graph. Okay, and then here's the question: use the graph to determine which of the following ordered pairs, and there are 4 here that I want you to look at, ordered pairs are solutions to the equation. And then you're going to answer yes or no. All right, so the first one, 2, negative 6. How can you easily determine if the ordered pair 2, negative 6 is a solution to this equation given its graph? All right, well, okay, based on what we talked about, in order for this ordered pair to be a solution to this equation, it has to lie on the graph. I'm going to repeat it again. In order for this ordered pair to be a solution to this equation, it has to lie on its graph. So look at 2, negative 6. Let's plot 2, negative 6. So 2 is the x value, negative 6 is the y value. So you start at the origin. So since 2 is positive, you go to the right 2. Since 6 is negative, you go down 6. So right 2, down 6. And so 2, negative 6 is right here. So that's 2, negative 6, right? So is 2, negative 6 a solution to this equation? The answer is yes, because it lies on its graph. Okay, so the answer is yes, all right? Because it's a point on its graph. Let's go to the next one, 4, 3. All right, so let's plot the point 4, 3. So my x value is 4, my y value is 3. So you start at the origin, you're going to go 4 units to the right, 3 units up, 1, 2, 3. So this is the point right here, 4, 3. So is the ordered pair 4, 3 a solution to this equation? The answer is no, because it does not lie on its graph. It lies off the graph, outside of the graph. All right, so the answer is no. Next one is 5, negative 9. So let's plot the point 5, negative 9. So 5, negative 9, you go to the right 5, down negative 9, and that's this right here. So here's the point 5, negative 9, the ordered pair. So is 5, negative 9 a solution to this equation here? The answer is yes, because 5, negative 9 lies on the graph. In fact, remember we talked about every point on this line, every real number, and there are an infinite number of real numbers here, is a solution to this equation. All right, so for part C, the answer is yes. And then finally, negative 6, 4. If I plot the point negative 6, 4, I go to the x is negative, y is positive. So I go to the left 6 from the origin. So left 6, so here. And then I go up 4. 1, 2, 3, 4. So here's the point, negative 6, 4. So is negative 6, 4 a solution to this equation? The answer is no. The answer is no, because it does not lie on the graph. Okay? All right, so that's very important you understand what we're talking about here. So because that idea is going to be important when we start graphing these, to really understand what it is that you're graphing. we are graphing the solutions to the equation, because those are the numbers, these are the ordered pairs that will make this equation a true statement. All right? And we could check if you want to. We could check, let's say, letter C. So let's check the ordered pair 5, -9. We're saying it's a solution, correct? Because it lies on the graph. But let's substitute back in here and see. So y equals -x minus 4. All right, so this is x, this is y. So y is -9, so I want to see if that's equal to a -x, which is 5, so that's -5, minus 4. A -5 and a -4 is a -9, and notice those are equal. Okay? All right, so that is this part. Now let's look at this. Okay, so what I want to do now is I want to graph linear equations of this form right here. All right, so remember at the beginning of our lesson, we indicated that there were two forms that we were going to look at. All right, remember that right here? So we're going to look at this form here, the one where y is by itself. That's always the easiest kind. That's the easiest kind. Now, you must always follow directions. The purpose of this lesson is for you to graph these by plotting points, okay? By plotting points. So that's the purpose of this lesson. Don't do it any other way, okay? So use plotting points. All right, so what I'm going to do is we're going to use grid paper, and so if you don't have a printer, you need to make sure that you draw your coordinate plane very carefully. You don't have to draw all these little grids in here, but make sure it's scaled properly. Okay. All right. So we're going to do the first one. Y equals 2x plus 3. So number 1, y equals 2x plus 3. All right. So we want to graph this. So you want to graph this linear equation. Notice there are two variables, x and y. All right. Now remember when we talked about graphing the solutions to this right here, y equals x minus 3. When we did that, we used a t-table, right? So that's what you're going to use when you're going to plot points. When it says plotting points, you're going to use a t-table. All right, so we're going to use a t-table, and we're going to do that here. So this is your x, this is your y. So x is always the column on the left, and y is always the column on the right, because it represents the ordered pair x, y. Okay, that's important. And as I said, whenever you have y by itself, that is the easiest kind to graph. Now, when graphing a line, to graph a line, you just need 2 points, but you could have one of those points incorrect. So we're going to use 3 points just to make sure that all these 3 points are collinear, meaning that they lie on the same line. Collinear, they lie in the same line. All right. Okay, so you can use any real number for x. Whenever y is by itself, that's easy kind, and you could use any real number for x. Whenever possible, it's always easiest to use integers for x. Okay, make things easy because it's easy to plot ordered pairs that are integers, and you saw that when we looked at this graph here, plotting the point 4, 3. So all these are integers. 4, 3, it lied on where those little grids intersected. So that's the easy kind. All right, so there was no estimating involved at all. So whenever possible, try to always have your ordered pairs, both x and y, be integers. It makes things a lot easier to graph, and you don't have to estimate where they're located in the coordinate plane. All right, so if you let x be 0, and 0 is always an easy number to use for x. So if x is 0, where you're solving for y. So where we see the variable x, you're going to substitute 0. So I'm going to put that here. So y equals 2 times 0 plus 3. All right. So where we saw the variable x, you substitute 0, because that's what I'm saying. I'm going to let x be. And now we're going to figure out what y is. So order of operation, you're going to multiply before you add. So that's 0 plus 3, which is 3. Okay? So when x is 0, y is 3. So that's one of your solutions. So remember, when graphing an equation, you are graphing its solutions. So 0, 3, the ordered pair, 0, 3, is a solution. So let's go ahead and plot that point. Since x is 0, I stay the origin, and y is positive 3. I'm going to go up 3. 1, 2, 3. So there's the ordered pair, 0, 3. Okay, right here. All right, now we're going to do another point. I'm going to use another positive number. Let's say 2, if x is 2. So if x is 2, we do the same thing I did with the first one. So y equals 2 times 2 plus 3. Using the order of operation, I'm going to multiply before I add. 2 times 2 is 4, and 4 plus 3 is 7. So I'm going to plot the point, 2, 7. So 2, 7, we'll go to the right 2 from the origin. I go to the right 2, and then up 7. So 2, 7 is right here. So that's 2, 7. Okay? Now, see, I could have messed up somewhere around here. So it's always a good idea to plot 3 points. Okay? Plot 3 points, because if you're doing this correctly, all of the solutions, see, that's a linear equation. All right, a linear equation, in the word linear equation, is the word line. And so when you graph linear equations, you're graphing a line. So this must be a line. So those points must lie on the same line. They must be collinear. So you can't have the other point being here, because then they're no longer collinear. Okay? All right, now I'm going to use a negative number just to show you what to do. So if x is, let's say, negative, let's do 3, negative 3. I get y equals 2 times negative 3 plus 3. So 2 times negative 3 plus 3. So where we saw the variable x, you substitute negative 3. Well, 2 times negative 3 is a negative 6. Negative 6 plus 3 is a negative 3. Negative 3. So I'm going to plot the point, negative 3, negative 3. So I go to the left 3 and then down 3. So there's the point. Negative 3, negative 3. All right. Now, remember, it says graph this line. So I want you to tell me what I found. Those 3 points represent solutions to this equation. All right. Or is that the only solutions to this equation? Does this equation only have 3 solutions? I'm hoping you say the answer is no, because you know that this linear equation has an infinite number of solutions. We just plotted 3 of them. Now I've got to graph the rest of them. Well, remember we said the graph of the linear equation represents the solutions. So if I take a ruler and I draw a line through those points, notice they're collinear. Those 3 points lie in the same line. So when I draw a line through them, make sure it extends it. Draw your arrow. Make sure you draw your arrow. Then now you have the graph of this equation. So the graph of this equation represents all of the solutions. Okay, you use 3 of them to plot the rest of them, to graph this line. And that's all that is. It is not a very difficult process. So that's how you graph a linear equation. And remember we said this is the easy kind because y is by itself. All right, so let's look at number 2. So number 2, let's suppose we had this for number 2. All right, here's number 2. So I want to graph this one, and number 2 is y equals negative 3x plus 1. All right, so that's the easy kind as well. Let me go ahead and use the grid paper. So let's graph. So this is number 2. Let's graph y equals negative 3x plus 1. Okay. All right, so we're going to use the t-table. The direction says by plotting points, right? So you must use the t-table. It says plot points, use the t-table. Okay, so we use the t-table. Here's your x, here's your y. Y is by itself, that's the easy kind. So if x is 0, I'm going to find out what y is, what my y value is. So I get y equals negative 3 times 0 plus 1. So wherever I saw the variable x, I substituted 0. Order of operations, I multiply before I add. Negative 3 times 0 is 0, and 0 plus 1 is 1, right? So when x is 0, my y value is 1. So there's the solution. So I'm going to plot that ordered pair. So 0, 1. So since x is 0, I stay the origin. Y is 1, I go up 1. So that's the point right here, 0, 1. Okay? Now that's only one solution. So when graphing a line, you want to graph all of the solutions, and they're an infinite number here. Okay, let's do another one. Well, when I say do another, I mean let's find another solution. So if x is, let's say, 3. If x is 3, I get y equals. Remember, we can use any real number. It's always best to use integers, and you want the, whenever possible, you want the y value to try and be an integer, so that way you don't have to estimate. It's not always going to be possible, but if you can, then go ahead and try to get those two to be integers, the ordered pair to be integers. It makes things a lot easier to plot, and you don't have to estimate. Okay, so if x is 3, I get y equals negative 3 times 3 plus 1. Negative 3 times 3 is a negative 9 plus, and then we get add that to 1, which gives me a negative 8. So I'll plot the point, 3, negative 8. So 3, negative 8, I go to the right 3, down 8, and that is here. So there's the point, 3, negative 8. Let's do one more. So let's say I want to plot the point. I'm going to put a negative in there. Let's say I want to plot the point. I'm going to let x be negative 1. So in place of x, I'm going to substitute negative 1. So I get y equals negative 3 times negative 1 plus 1. Negative 3 times negative 1 is a positive 3, and 3 plus 1 is 4. All right, now, remember, the reason for that third point is to make sure that those 3 points are collinear. I could have easily made a mistake here, right? So if they're not collinear, then I made a mistake somewhere. So you got to go back and figure out where that mistake is, because those 3 points must lie in the same line. They must be collinear. So if I plot the point negative 1, 4, that is here. So here's the point, negative 1, 4. Okay? And then if I use my ruler and then connect those points, what I'm doing now, remember, you can't stop there. If you stop there, then that implies you don't really understand what it means to graph a line. To graph a line means you're graphing all of its solutions. I've only graphed 3 of them. You want to graph all of them. So there's an infinite number. So to graph all of them, you use your ruler, and then you draw a line through those points, and you are shading in. I didn't graph this very well here, but you are finding all of its solutions. So any point on this line, and remember the arrows keeps on extending, is a solution to this equation. And that's all you do. Not very difficult, right? Not very difficult at all. Okay, now let's look at this one though. Okay, so let's look at number 3. So number 3, we want to graph y equals, and it's y equals 1/2 x minus 5. Now notice this time I have a fraction. And remember what I said earlier. It makes things so much easier for you in terms of graphing if the x and y coordinate are integers. So when you have a fraction, you want to think about this. You want to think, all right, I don't want to graph or plot fractions. What I want to do is choose an x value that will make this y value an integer. Okay? All right, so here's the way you're going to do this. You see you're multiplying x by 1/2. So since I'm multiplying x by half, choose a value of x that is divisible by 2, the denominator 2. So meaning that you could choose any even number, right? Any even number is divisible by 2. So I'm going to show you. If x is 4, is my y value going to be an integer? It better, because I'm multiplying it by half, which means I'm dividing by 2, right? So let's check. So y equals 1/2 times 4 minus 5. Well, what is a half of 4? A half of 4 is 2. And what's 2 minus 5? 2 subtract 5. 2 subtract 5 is a negative 3. So hey, I got an integer, right? No fraction, so that's easy to graph. That's easy to plot. So 4, negative 3, I go to the right 4, down 3, and there's the point 4, negative 3. Okay, now let's do another one. So remember, you're substituting for x, you're multiplying it by a fraction, so look at the denominator. Always look at the denominator. You want to choose a number for x that's divisible by 2. Well, that's easy because any even number is divisible by 2. Okay? So for example, if you use, let's say, 10, if you use 10, let's say, I get y equals 1/2 of 10. Ooh, let's not use 10 because it only goes up to 9. But let's just finish it off though. 1/2 of 10 minus 5. Half of 10 is 5, and 5 minus 5 is 0. So if this grid was large enough, you could plot the point 10, 0. So 10, 0 would be about here, right? So that would be 10, 0 right here. Okay, so let's do, let me extend this further. All right, so let's go ahead and let x be, let's say, negative 2. Negative 2. So let's use a negative just to show you what to do. So if x is negative 2, I have y equals 1/2 of negative 2 minus 5. A half of negative 2 is a negative 1, and a negative 1 and negative 5 is a negative 6. So I'm going to plot the point negative 2, negative 6, because that's a solution. So negative 2, negative 6, you go to the left 2, down 6, which is here. All right, and this isn't too far off, so I'm just going to leave it like that. So those are my 3 points. I kind of scaled this pretty well. So those are my 3 points. So this is the point here, negative 2, negative 6. So then make sure those points lie in the same line, and look, they do, right? They do. They lie in the same line, and then draw your line. And so there's the graph of this equation. So remember, you got to draw your line, because if you don't, remember what we mean by graphing this line. You want to graph all of its solutions. So if you only put those 3 dots, you've only found 3 solutions. There are an infinite number of solutions here. So you got to draw your line to represent those solutions. Let's do another one with a fraction. So let's look at this one. So this is going to be number 4. So in number 4, let's suppose we had this one. In number 4. Okay? Number 4. We want to graph y equals 2/3 x plus 4. 2/3 x plus 4. Okay, now listen carefully. So and the directions will say plotting points. All right. So remember we talked about earlier. You want to try and get these x and y to both be integers if possible, because it makes things a lot easier to graph. Or to plot. So if you look at the value of x that you want to choose, look at the denominator. You want to choose a value of x that's divisible by 3. Okay? Like 0. 0 is divisible by 3. 0 is divisible by 2. So when I did this one here, I could have used 0 for x if I wanted to, because 0 is divisible by 2. Look, 1/2 of 0 is 0. 0 minus 5 is a negative 5. So look, here's 0, negative 5, right? Okay. So if x is 0, I get this. I get y equals 2/3 times 0 plus 4. Well, 2/3 times 0 is 0, and 0 plus 4 is 4. Oops, 4. So I'm going to plot the point 0, 4. So 0, 4 is a solution. So I'm going to plot that point, 0, 4. So you're going to stay at the origin since x is 0, and then you're going to go up 4. 1, 2, 3, 4, right here. All right, so there's the point 0, 4. Okay? All right, now we need 3 points. Okay, so listen carefully. You want to choose a number for x that's divisible by 3, because if you don't, you're going to end up dealing with fractions. You end up dealing with fractions, and you don't want to have to deal with fractions if you don't have to. So give me a number that's divisible by 3. So 3, right? 3 is divisible by itself. So if x is 3, let me go ahead and do it right here. If x is 3, I get y equals 2/3 times 3 plus 4. All right, 2/3 times 3, right? So think about what we're doing here. You're saying 2/3 times 3. Remember, 3 I can write as 3 over 1, and then you can reduce first. The 3's divide out. So what's 2 times 1? 2 times 1 is 2. So 2/3 of 3 is 2. And what's 2 plus 4? 6. So I'm going to plot the point 3, 6. There's another solution. So I'm going to plot it. So 2, 6, to the right 2, up 6. So there's the point 2, 6. Now don't draw your line just yet, because I could have made a mistake on one of these. So let's plot one more point. And I want to go ahead and plot let x be negative, just to show you what to do. So give me another number divisible by 3. So we chose 3. I can choose negative 3 if I want to. So negative 3. So I get y equals 2/3 times a negative 3 plus 4, right? So I have this 2/3 times a negative 3, which same thing as negative 3 divided by 1. 3 to 3 is 1. 3 to negative 3 is a negative 1. What's 2 times a negative 1? 2 times a negative 1 is a negative 2. So 2/3 of a negative 3 is a negative 2. And what's a negative 2 plus 4? A negative 2 plus 4 is a positive 2. So my y value is positive 2. So here is another solution. And so if I plot that point, hopefully those 3 points lie in the same line. They are collinear. So let's see. Negative 3, 2. I go to the left 3 and up 2, and it sure is. Okay. So let's double check. Let's use a ruler to double check. And so let's see. Well, something's wrong. Let's see what I did. So 0, 4 is here. 3, 6 is, oops, yeah. So see what I did? So notice when I did this, they don't line the same line. So what do you think I did? Look at the 2, 6. I'm sorry, the 2, 6. See, I said 2, 6, right? What should have I put? 3, 6. So it's 3, 6. So 3, 6 is here. That's 3, 6. I don't know why I said 2, 6, but 3, 6. So this right here is not a solution. So I'm going to have to use liquid paper to remove that. So let me go ahead and do that real quick. Okay, so let's see. All right, so now you see why it's important to use 3 points. Because see, when I did this, I plotted the point 2, 6 instead of 3, 6. So be careful. That's why it's important to use 3 points. And I'm glad I kind of did that just to see why, just to show you why it's important to use 3 points. Okay? All right. So then now notice they are collinear now, right? So I'm going to draw my line. Now remember, if you don't draw your line, you're indicating that this graph right here only has 3 solutions, and you know that's not true. That graph has an infinite number of solutions. So go ahead and make sure you draw your graph. And so there's your graph. Very simple, not difficult at all, right? Okay, let's look at number 5. So number 5, we have, let's see, let me get a sheet of paper. All right, so here's number 5. We want to graph y equals negative 3x divided by 4, and then plus 2. So negative 3x divided by 4 plus 2. Okay, same idea we've been doing, right? You have a fraction. So and you want to do this by plotting points. So here's my x, here's my y. So it's very helpful if you can get x and y to be integers. All right, so if I want x and y, the ordered pair x, y to be integers, then I got to choose a value of x that's divisible by 4. All right, so again, 0. So if x is 0, I get this. I get y equals negative 3 times 0 divided by 4 plus 2, right? Well, what's negative 3 times 0? Negative 3 times 0 is 0. And what's 0 divided by 4? plus 2? Well, 0 divided by 4 is 0. And what's 0 plus 2? 0 plus 2 is 2. So I'm going to plot the point, the ordered pair, 0, 2. That's the solution. That's the solution to this equation. Kind of makes sense because, look, if x is 0 and y is 2 equal to 0 plus 2? The answer is yes. Okay? So 0, 2. So 0, 2, I stay the origin, go up 2 right here. So there's the point, 0, 2. Now, let's pick another number that's divisible by 4. So another number divisible by 4 is 4, right? Use 4. So I get, I'm going to put that here. So I get y equals negative 3 times 4 divided by 4 plus 2, right? And I just want to remind you, you could do one of two things here. You could multiply the numerators. You can multiply the numerators, and you can get negative 12 divided by 4 plus 2, just like I have. And then negative 12 divided by 4 is a negative 3, and a negative 3 plus 2 is a negative 1, right? But what I want you to remember is this, though. Okay, think. So you have to know all the different ways you can do stuff. That helps you if you have all that in your toolbox. So do y'all say I could reduce the 4s? And so what's negative 3 times 1? Well, that's a negative 3, which is what I had here. Okay? All right, so the ordered pair 4, negative 1 is a solution. So I'm going to go ahead and plot that. 4, right 4, down 1, right here. 4, negative 1. That's a solution. Okay, let's do one more because I could have made a mistake, right? Just like I did in that previous problem. So let's go ahead and say 8. Let's go ahead and let x be 8. If x is 8, I get y equal, and put that here, y equals negative 3 times 8 divided by 4 plus 2, right? All right, so let's kind of use this right here. So just to remind you how to do this. So negative 3 times 8 divided by 4. Well, 4 into 4 is 1, 4 into 8 is 2. And what's negative 3 times 2? Negative 3 times 2 is negative 6. So this becomes negative 6 plus 6, right? And what's negative 6 plus 6? 0. So I'm going to plot the point 8, 0. So 8, 0, oops. Let's see. Oops, I'm sorry. So that should be not 6. Well, I'm not sure why I put 6, but 2, right? 2, right here. So that's 8, 2. 2, negative 6 plus 2. Negative 6 plus 2. Negative 6 plus 2 is a negative 4. So 8, negative 4. We'll get that correct. 8, negative 4. So let's go through this again. Be careful when you're writing, when you're transposing stuff, because that's plus 2. And notice I put 6. I'm not sure why I put 6, but I put 6 there. So I knew something was wrong because they were not collinear. So always go back and check if you see something's incorrect. And that's going to happen, just like it's happening here. All right, so this is negative 6. Negative 6 plus 2 is a negative 4. So I'm going to plot the point 8, negative 4. So 8, negative 4, go to the right 8, down 4, and hopefully they lie on the same line, right? 8, negative 4. 8, negative 4. So hopefully they lie in the same line. So let's see. 8, negative 4. And they sure do. All right, so let's go ahead and, now remember, all you did is graph 3 points. You found 3 solutions. You want to, when graphing a line, you want to find all of the solutions, and they're an infinite number, so you're going to draw a line. Just like this with the arrows, okay? All right, so all we did in this lesson, and let me just kind of summarize. So we graphed linear equations, and in this lesson, all we did was graph linear equations where y is by itself. In the next lesson, we're going to look at the one that's in standard form. Okay? All right. So that is the end of this lesson on graphing linear equations in which y is by itself.